Hello, this is 6.3. We're moving on to medians and altitudes of triangles. And so here we start with some definitions. The median of a triangle, the centroid, the altitude of a triangle, and the orthocenter. So the median of a triangle is the segment from a vertex. Remember, the vertex is like the point on a triangle to the midpoint of the opposite side. So that is a median of a triangle. So if I were to have a triangle, the vertex to the opposite side of it, that is your median. Okay, the centroid is the point of concurrency inside the triangle. The altitude of a triangle is the perpendicular segment from a vertex to the opposite side or to the line that contains the opposite side. Altitude is also another way we can say height. It also gives us the height of a triangle. The orthocenter is the point of concurrency. So remember, that's where this is the point where all the lines cross or meet of the lines containing the altitudes of a triangle. So those are the 4 definitions that we're going to run into today. We'll also talk about 2 more theorems, and that'll be the centroid and the orthocenter. Okay, so theorem 6.7 is the centroid theorem. The centroid of a triangle is 2/3 of the distance from each vertex. So each vertex to the midpoint of the opposite side. So for example, I have the medians of A, B, C meet at point P. So P is your point of concurrency or your centroid. So P is the centroid. Okay? P is the centroid, also your point of concurrency where all your lines meet. So this says that AP is equal to 2/3 of AE, so that whole thing. So from the vertex to the middle, it is 2/3. Vertex to the middle means it's 2/3. Okay? And it also says it for the rest. So from CP, so vertex to the middle, is 2/3 of the whole thing DC. And the same with PF. Okay? So let's do an example. So I have R, I'm going to put this point as U, the top vertex is S, and I have V as a midpoint, I have T, and W. And we're going to make Q, this point here is our centroid. say we want to find SW and QW, okay? And we are given that SQ is 8. So we need to find SW, the whole thing, as well as QW, our small part here. So to find SQ, well, we know that SQ is going to equal 2/3 of SW. So SQ from the vertex to the inside is 2/3 of the entire thing. So SQ is 8. So 8 equals 2/3 SW. In order to move or to get rid of our 2/3, we want SW by itself. We need to multiply by its reciprocal. So that means these two will cross out. And so I have 3/2 times 8 equals SW. And when I put it in, I have 12 equals SW. So the whole thing is 12. So now to find QW, QW equals SW minus SQ. And so that means SW is 12 and SQ is 8. And so QW is 4. Alrighty. Another shortcut to think about this, or if I want to find QW, it is always half of my line to the vertex, or from my vertex to the midpoint. So half of 8 is 4. So I'll always keep note of that. It's a nice little shortcut to know. But if we forget, note that QW is the difference. Flip over to the back side. I have our Orthocenter theorem, or our course concepts for the Orthocenter. So the lines containing the altitudes of a triangle are congruent. So the point of concurrency is called the orthocenter. So the lines containing AF, BD, so vertex to a side, and CE all meet at orthocenter G. So it might not have been the very center of the triangle, but they do note that G is the intersection, or this is where they cross and meet, point of concurrency, also known as the orthocenter. So let's try a couple of practice problems. So it says QN is 33, and we need to find PN and QP. So let's look at what's given. So QN, so that means this entire thing here is 33. And I need to know what's part of that. Well, I know PN from the vertex to the midpoint, P, is going to be 2/3. So PN must equal 2/3 of my entire thing, which is QN. But I'm already given what QN is, and that's 33. So PN equals 2/3 times 33. 33 times 2 is 66. And 66 divided by 3 is 22. So PN is 22. Now I need to find QP. Well, I know that if I were to have this entire thing equal 33, all I have to do is subtract. So I have QP must equal PN. Sorry. QN minus PN. So QP equals 33 minus 22, which is 11. So let's try the same for example 2. So it says QN is 45 degrees. Or not 45 degrees, just 45. 45 degrees deals with angles. So, but I know that PN from the vertex to my midpoint is 2/3 of it. So PN, again, is 2/3 of QN. PN is 2/3 times 45. And when I plug it in, PN is 30. So now I need to find QP. So I know if I were to subtract, I should get my remaining part. So QP equals QN minus PN. QN is 45. PN is 30. So QP equals 15. And again, if you notice, half of 30, or 30 divided by 2, is 15. 22 divided by 2 is 11. Let's try number 3. It says QN, the entire thing is 39. Okay, so again, I know that from the vertex to my midpoint, or my point of concurrency, is 2/3 of it. So PN equals 2/3 QN. So 2/3, 39, which equals 26. So PN is 26. So if I'm trying to find the rest of it, QP, I have to take the difference. So I now have 39 minus 26, which equals 13. Note, half of 26 is 13. So keep this as a shortcut in mind when trying to find the other side. Move up to the next page. Now, part 3, we are only going to do like a part 1, part 2. So we'll do 4 and 5, and we're going to do 6 through 11 at a previous time on notes. But in the meantime, we are doing 4 and 5 together. So it says we need to find CD and CE. So CD and CE. We need to know what both of those are for 4 and 5. So it gave us DE. So it gave us this part. So remember when I said that shortcut? So if I took this part and cut it in half, I get the rest. So what if I multiplied? So we can have 7, or DE, DE times 2 will give me DC. DE is already given to me. So 7 times 2 is DC. So DC equals 14. Or CD is 14. Now CE is the entire thing. So all I have to do is add them together. And 14 plus 7 is 21. So this is with the shortcut answer if you double it from the opposite side. 14 is definitely half. So number 5, let's see if we can try it again. So here I have 12. Now what if I doubled it to get the rest of it? So that means CD is 24. And I want CE, which is the entire thing, which is 36. So all I need to do is take DE times 2, which will give me the rest of my vertex. Alrighty, so that's with the shortcut answers. I always like a short way. There is a longer way, but if you notice the pattern, please use it. So note the difference between this. This is 2/3 of an entire, and for midpoint to the opposite side is always going to be half of the midpoint to the vertex. Alrighty, that concludes 6.3 notes. Until next time, we will finish up 6 through 11. You do have that worksheet. It ties in with 6.2 and 6.3, as well as you have a nice little puzzle. So make sure you complete all those sentences. You have a puzzle and a worksheet. Thank you so much.